OK, this is all about DNSSEC. DNSSEC is a really cool topic. This is one of those topics that takes network and cryptography and puts them together. And the result, I think, is very beautiful. So let's see it in action. So to talk about DNSSEC, we should first remind you what DNS is. Remember that DNS is built on the two big ideas. One is that if a name server doesn't know the answer, they will redirect you to someone else who can help. And the second big idea is to arrange the name servers in a tree and give each name server a different zone that they're responsible for, so that if someone asks a question, they get redirected to name servers further down the tree until they get an answer. This was implemented all using records that could be cached. Records had these data types, and they were put in sections depending on the purpose of the record. And DNS put all of these records in a UDP packet for efficiency. And the last thing we said was that DNS was not secure by itself. There was no cryptography, which means that man-in-the-middle and on-path attackers can do damage and poison the cache. Malicious name servers can poison the cache. And off-path attackers using the Kaminsky attack might have a chance to poison the cache as well. Today, we'll try to solve all of these problems by designing a secure version of DNSSEC that does involve cryptography. So first, we'll look at an alternate design, really briefly, called DNS over TLS. We'll think about why that's useful and why we might not want that. And then we'll go into DNSSEC. We'll start high level, then do a bunch of implementation details, and then think about how it's actually used. So this is the outline. That's all I got. OK. So I know you're all excited to get into DNSSEC. It's a really cool protocol. But first, let's think about a different approach that you could take to secure DNS called DNS over TLS. So if you think about DNS and its various threats, like malicious name servers and network attackers, all of their attacks had to do with cache poisoning. In other words, they were modifying the data as it was being sent to you, and you receive some modified, tampered data that you put into your cache. To defend against all of those attacks, we want integrity. If you think back to all the cryptographic properties, integrity is the one that stops attacker tampering. So we want integrity on all of our responses. Now, something that is a little bit unintuitive is the fact that we don't actually need confidentiality on the responses. Think about what is showing up in the DNS responses. It's usually records that say things like, the IP address of eeks.berkeley.edu is this number, or this name server is responsible for .edu queries. That's not private information. Anybody can ask for those DNS records. It's not like we're trying to hide that information from anybody. So we don't really need confidentiality on the responses, if you think about it. The main thing we're worried about is that the responses are correct and untampered. So DNS results are public. We don't really care if an attacker can read them.